Hello friends, welcome back. In the previous video, we were talking about how wires work, how we find out our motherboard code and pass control to it. We also implemented the MBR to load our second stage bootloader. In this video, I'll show you how to implement the second stage bootloader to load our color and pass control to it. Here's the main task we have to do. First thing we do, we just find out where the color is located and load it into the physical memory. After that, we have to set up the environment for it, like enable protected mode. The protected mode is the main mode that CPU running and is unleash the CPU real power, like enable the future virtual memory, and we no longer have the limitation of the 16-bit mode, so we can accept many addresses after that. After that, we have to set up the runtime environment for the kernel. Finally, we just pass control to it and jump to our C code. Here our hard disk image. We already implemented the first 6 sectors in the hard drive. The first for our MBR and the next 5 for our second stage bootloader. In this video, we will load the color from leg 5 sector to the physical memory. Let's look at this memory now. We already have the free region from the address 10,000, so we will spend it for our protected mode color. Here is our loader code. The first thing I do is just load the color from the hard drive to the physical memory, and using the same service, extended read service. So I already mentioned it in the previous video, and the different thing here we just now in this time we just load into the 10,000 address, and we will load from the sector 7. Next thing we do is set the video mode, because when we running in the protected mode, we no longer can access to the BIOS service, so we have to enable the video mode to like print message and graphic to our console. The next thing is switch to protected mode. We have made 3 steps. First is disable interrupts. Second is load the global descriptor table. The concept about the global descriptor table is quite complex, but I think you just have to know about the main idea about this. It's just like we describe a memory region for the CPU, tell the CPU about the length, about the base address, about the attributes like readable or writable, and we no longer have to use segment register anymore. For this table, we have 3 entries. First entry is none, and the second entry is spent for our code segment descriptor, and the final entry for data. It is quite similar in C, and that is the reason why people say C is very close with the machine code. You can see here is like the array have 3 elements, and the first element is just none. The second is our code segment descriptor, and the third is data segment descriptor, and we spend 8 bytes for each. And we pass the pointer to this command. It's very similar like C, right? You just call the function and pass the parameter to it. And because we don't deal with the interrupts, so in this time we just pass the loon pointer to the interrupt descriptor table. The final step to enable the PM mode is we have to set the bit 0 of the control register. After that, we already running at the PM mode. We have to perform the long jump and using the code segment here. You can see now we don't have to using the segment register anymore. Now just pass like entry, second entry is code segment descriptor, right? And we just jump to our entry. And here we have to tell the assembler that our code will running at 32-bit mode, and so from that you can see here. Okay. First thing we have to do is just clear all the segment register because we no longer can accept to this, and set up the stack pointer point to the same address before. After that, we jump to the color main function using the code segment descriptor. And our color code will be located in the 10,000 address. Here, now look back and look at to our color code. I do nothing, just using the address like this address is our video device, so I just point to this and print the character to make sure that our color is running. And in make file, we have to build our colors in the 32-bit mode, right? So here I specify flag M32. Also, we have to using the linker to tell the linker that our color will running at the address 10,000, and and the output format will be the binary. Okay, now just make to generate our boot image. Here you can see everything is fine, and in this time I just send the QEML rule. Here you can see the K character already print here. And after that point, our color already running right. After that, we can set up more like set up the interrupt descriptor table to capture the like a hardware interrupt, and using the timer for the context switch and implement scheduler and many things after that. But in this time, I just implemented the second state bootloader to load the kernel, so it's done. I hope you learned something. So thank you for watching me. Bye bye.